All right, we are here with Adam Martin. He is the biologist for the Western Fisheries District for the Kentucky Department of Fish and Wildlife, as well as the chairman for the Black Bass Management Team. Adam, how are you today?
I'm good. How are you guys?
Good.
Doing pretty good. We have a couple questions for you. We're glad you're here, first of all. Thank you for coming. I'm going to let Ryan take the main seat on this because this is more of Ryan's interview, I would say.
I've been looking forward to this one. I got a lot of questions, and I think a lot of people have a lot of questions. So hopefully this will educate some on what we've got going on.
Yeah, I agree. There's definitely no shortage of misinformation or just a lack of information being put out.
Conspiracy theories.
There's a few of those for sure. Yeah.
So let's just dive right in. You invited me this week to go to the 2024 Black Bass Management Summit hosted by Fish and Wildlife there in Frankfurt. So we went to that earlier this week. That was a great event, I thought. And I really appreciate the invite, but just kind of wanted to dive into that and do kind of a recap over that event and kind of things that were talked about and just what we discussed there. So obviously there was several topics brought up, and it was talking about the bass fishing as a whole in the state of Kentucky. So not just Kentucky and Barkley Lakes, but all of our other lakes across the state. So, some of the things that we talked about were Florida bass stocking, the genetics of the Florida bass, stocking bait fish, which we don't seem to have a shortage of that here on Kentucky Lake. So it doesn't really fit into our agenda here. But a lot of different topics. And I thought it was a really cool event because the misconception I feel like is that the state is working against us fishermen. And that was, in my opinion, the state saying, hey, we want to hear from you. So that was a really cool event. And I know obviously that's what you do on a daily basis, but was there any takeaways that you had from that? Maybe stuff that you heard from the anglers that you want to see or that they want to see and going forward?
I think you summarized it pretty well. And that's the first statewide bass summit that we've ever held. And a lot of the goals were those things that you stated, like oftentimes anglers and even some biologists, you kind of get on your own team and it becomes this adversarial relationship where anglers are all fired up to go to a public meeting and fight against whatever the biologists are saying. And then you get biologists sometimes who are like, these anglers don't know anything about what they're talking about. And to me, that attitude is always completely ridiculous. Like if there's a group of anglers that doesn't know what's going on, that's the biologist's fault, not the angler's fault.
Yeah.
So it's kind of everybody at the end of the day, biologists and anglers want better bass fishing opportunities in their local water bodies. And the more those groups can get on the same page and cooperate, the better off things are going to be. And a lot of that responsibility falls on the biologists because we're not particularly good communicators. We do a lot of work all the time. We don't showcase a lot of that work. It's pretty rare for us to tell a good story about what we're doing and communicate efficiently. So that provided a really good opportunity to do stuff like that. And I think it's been a success and we'll likely do it again in the future.
Yeah, I really enjoyed it. And the one thing that one of the anglers brought up there is, what is our goal as a whole? Do we want more bass or do we want more big bass? And ultimately, obviously we talked about stocking Florida bass, which is obviously to grow bigger bass. Well, if that's not what we want as a whole as anglers, then we don't need to do that. We need to focus on how do we get the most amount of fish, and obviously we'll dive into that with carrying capacity and all that kind of stuff as well. But there's a whole bunch that goes into it, of course. But I really liked it just because it showed me that the state is making an effort to give information to the anglers and take feedback from the anglers to say, hey, what do you want to see? What do we need to work on? So it was a really good event. And again, I appreciate the invite there. So diving in a little bit more specifically to Kentucky and Barkley Lakes, you handle the Western District here in Kentucky, which is Kentucky, Barkley, and Lake Bashir. Is that correct?
Those are the major reservoirs. Yeah.
So obviously anyone that knows anything about Kentucky Lake knows about the ups and downs that we've dealt with over the last several years. So what would you say that we kind of started to see the downturn? When did we start to see that?
So we have pretty good records of the bass populations going back to about 1985. And we have, really good sampling every year since then. So we know what the ups and downs have been. When you look historically in the early 80s, mid 80s, bass fishery wasn't very good. Then there was a big drought cycle that occurred in the late 80s. And that actually spurred on these really good year classes. We had higher levels of what we call recruitment, which is just the number of small fish entering the water body, through reproduction each year. And that really did well. It sustained some pretty good fishing in the 90s. It declined again with some poor year classes, poor recruitment in the mid 90s. And things were really bad in like 1997, 1998. That's when we went to a 15-inch limit. And, everybody was up in arms about that, and rightly so. You want fishing to be as good as it can be. So there was a lot of excitement,
sure,
to say about the downfall of the lake at that time. And then 2000, 2001, we had some stellar year classes that really bumped things up. Fishing was pretty good, early 2000s. 2007, we had an amazing year class and several strong year classes after that. And that bumped up those catch rates to basically double what they had been in the past. So over the period of about 2008 to 2014, Kentucky Lake was at its peak, Barkley in a similar situation. That was when you had, 200 fish days on a ledge, 150 fish days. Everything was looking really, really good. Then we had some poor year classes in around 2014 and 2015. That kind of led to lower and lower numbers. And we ended up, a lot of anglers were very upset about the lack of fish in, say, 2017, 2018, and in a little bit into 2019. Now, luckily, we had our best year class on record in 2016, which really started to get things going on a rebound. And then we've had our past 4 spawns have been all above average spawns. I haven't crunched the numbers on last year's yet. I've collected the fish and the otoliths that we used to age those fish, but I don't know exactly how many. My sense of it is that it's going to be in at least the top 5 for that 40 years of data that we have, if not possibly the best that we've seen. Same thing on Barkley. Really stellar year class last year. So the fishing has improved dramatically over the last 5 years, thanks to that return of good recruitment. And really, I don't think we've seen anything yet in terms of abundance of fish. I think it's going to go up and up for the next couple of years in terms of keepers.
That's good to hear. One thing that you mentioned there was, I believe you said there was a drought, which led to good years of spawns there, good recruitment years. So as fishermen, we really like when the water comes up because it puts fish up in the bushes and it's fun. You're catching them flipping, whatever. It makes it really fun to go catch fish. What is the drought and flood impacts on a spawn?
So generally speaking, the environmental impacts on the spawn, year class, and recruitment are extremely high. And a lot of people want to blame it on different things. The environmental effects have the strongest effects by far. And when we look historically, we know what the year classes have been over time for each year. So we kind of have a score of how good that year class was. Well, we can take that and then compare it with environmental conditions. A lot of that work early on was just looking at seasonal variables. So how much rainfall did you have in the spring? What was the average water level in the spring? Average water temperature, that kind of thing. So big seasonal averages. And what you found when you looked historically was that during years where you get a lot of rainfall, the lake floods, even by a couple of feet, it's generally a poor year class for largemouth bass. Now, conversely, it's usually a good year class for white crappie, which on the one hand, it's frustrating that you can't have a year with good recruitment of both, since those are our top species. But it does provide some variety. And that's, in my opinion, what's extra special about Kentucky Lake and Lake Barkley is you can go out there You can catch a 10-pound largemouth. You can catch a 8-pound smallmouth. You can catch a 4-pound white crappie or black crappie. There's a lot of variety out there. I'm not going to say you're going to catch those on back-to-back casts. Either one of those would be like greatest fish of your life fishing the lake. But it's possible to do so. And not a lot of lakes have that opportunity. So getting back, those environmental conditions, a drought year was typically a better bass spawn when you look historically. And there was always a little bit of debate about why that was the case. Because there's a few things that happen whenever you have a big drought cycle. Because everything is kind of, it's not just the lack of rainfall that's the variable. It also creates clearer water. The water's lower. That clearer water allows more light penetration, which allows more vegetation. So you get more grass in years that are drought years. And kind of the conventional wisdom is that when you have more grass or submerged vegetation in a reservoir like Kentucky Lake, you get better recruitment because you get better survival of those small bass and small fry. And that was kind of the dogma for years and years. What's been really interesting at our lakes, for one, Barkley never had submerged grass anywhere north of Linton, which is kind of right at the state line of Tennessee. And it had similar recruitment trends with Kentucky Lake that kind of went hand in hand. So that kind of, punches a hole in that theory of grass is important for recruitment of bass in these lakes. Because Barkley, again, the trends were similar, didn't have grass. But even more so in recent years, in 2015, we had a unfortunate natural spawn of grass carp within the system. Those grass carp seem to have decimated. Well, I think decimated means reduced by a factor of 10, but it did more than decimate. It, eliminated, yes, the submerged vegetation that we had just a year prior. And we haven't had submerged vegetation since then. So we've had essentially 8 years of Kentucky Lake with no grass. And some of those years have been some of our best and some of our worst year classes for bass. And the droughts and the floods still happen, and those still correlate. But the amount of submerged vegetation doesn't really seem to be a factor. And that's something that's, it's cool that you can look at that as an experiment. I wouldn't have wanted the grass carp here, but it does allow us to make that comparison without the confounding variable of, the droughts and the vegetation were always linked in the past. Now they're unlinked.
Sure. So, which, that's one of the topics that I wanted to discuss was grass in Kentucky Lake. That's been a huge hot topic over the last several years since the grass has gone away. I moved here in 2013 to go to school at Murray State. When I was a freshman, I want to say you could find grass nearly all the way up to Ken Lake. And then the next year it was Blood River. And then the next year it was Paris. And then after that it was gone, or maybe still some by New Johnsonville, but then essentially it was gone. Do you have any theories or do you have any ideas of why that happened annually, why there was a decrease further south every year?
Yeah. Those relationships are really well established and researched. The primary factor is going to be light penetration. That's what limits the vegetation growth in Kentucky Lake and Lake Barkley. So you need, water attenuates the light from the surface. And, that's a fancy way of saying it gets darker as you get deeper because it just absorbs or reflects or refracts those light, waves as they come in. And you need about at least 1% of the light level that's available at the surface to be able to reach the bottom for those plants to start growing. Now, what's problematic for growing grass in our lakes is we have a 5-foot drawdown. So a lot of times in the summer, we would have adequate light penetration on the bottom in those areas, and you'll see some grass growing kind of in the shallows, which is where that light penetration is the greatest, higher light levels. But obviously, come September, really starting after July 4th weekend, they start dewatering that drawdown zone, and the lake drops 5 feet, which dewaters all those plants, which just got started. So that's always been kind of the bottleneck for getting grass established in Kentucky Lake or Lake Barkley, and which is why you don't see as much, if at all, on Lake Barkley compared to Kentucky, because Kentucky's so much clearer. Now, what's happened over time is you see great variations in the amount of rainfall in a particular year, which affects water clarity. You get more erosion, more watercolors, more stained water that shades out those plants. And that is what leads to those interannual fluctuations that we saw in the lakes past. When you got here in 2013, you got here a year after one of the biggest droughts in the area, 2012. I remember I was doing a creel survey for the department during 2012. It did not hit summer pool until like basically July 4th weekend.
Right when it comes down.
I was on Barkley and I had to navigate at winter pool the whole time, except for like 1 week. That was a lot of fun. That was back when mapping technology was not what it is today.
Sure.
So I was there with a paper map lining up points and nope, that hit gravel. I can hear that. So yeah, when you have a drought year like that, not only the water stays lower sometimes, but it's also a lot more clear because you have less sediment washing into it and you can get grass established. Now, if it establishes, let's say it's 6 feet deep, which it definitely does and can, then it no longer gets dewatered. And then it can establish for quite a few years. And you often see kind of an additive or cumulative effect there where the vegetation itself will collect some of that sediment and cause it to drop out and get a little bit more light penetration in those areas with grass. So it's kind of they work together to create that ideal environment. And of course, since then, the environmental conditions haven't mattered very much. We still would be seeing those same fluctuations if it were not for the grass carp.
Gotcha. So with that being said, basically what I took from that is the dirtier the water, the less grass you're going to have grow, essentially.
Yeah.
Because the light can't penetrate.
In layman's terms.
Yeah. So on the north end of the lake, I've heard stories of early 2000s. There was grass everywhere on the north end of the lake. And, especially over on the east side of the lake. And the north end of the lake generally is clearer than the further south you go. So what happened to that grass?
Mm-hmm. Yeah. And some of it is the climate suitability of the invasive grasses that we had at that time, which is primarily Eurasian water milfoil. And there are different varieties of that. Some of them do better in warmer climates. Some of them do better in colder climates. So that's part of the issue there. And of course, there was some herbicide control that was done by TVA. They haven't done really any widespread herbicide control of vegetation since 1997. So it's been a really long time since they've done that. There's always rumors about them doing that. And I'm sure there are
helicopters and
it's, if the grass disappears and was there yesterday and gone tomorrow, you got to wonder what happened.
Yeah.
There are always stories of Black Hawk helicopters and underwater pipes distributing herbicide and emitters placed on barges as they go upstream, that sort of thing. Yeah. The reality of that is it's extremely expensive to treat vegetation in that way. It would cost millions of dollars to do it in Kentucky Lake, and they really have no desire to do it. It doesn't clog up the turbines. I don't know whether you've seen the one they have on display down there below Kentucky Dam.
Yeah.
You might imagine how much hydrilla that would take to clog that particular turbine. It's not a factor. They do occasionally allow the treatment of areas around certain docks where, a lakeside owner wants to get rid of the vegetation. So it's mostly about access. They might clear around a boat ramp or something like that. But again, they haven't had to do anything in years, and there hasn't been any widespread application since 1997. At least that's what I've been told. Our department doesn't do any kind of treatments on Kentucky or Barkley.
So with that being said, like you said, we dealt mostly with milfoil, and everybody, it's like every year, everybody's like, are we going to see any more grass or, whatever. And I think everyone's kind of talking about that milfoil and hydrilla coming back in the system. But one thing that's recently I've seen more and more people talking about that they've caught is the freshwater sponge type grass.
Yeah.
What is that? And is it any benefit? Will we see more of it?
I don't know whether we'll see more of it because it's been really interesting. There's freshwater sponges that are all over the place. Typically, and they have different body forms they can take. Usually it looks kind of like moss. So it's kind of like a mat, and you'll flip over a rock and there'll be a freshwater sponge attached to it. And those are fairly common. This past year, I've had a lot of anglers send me pictures or even bring it in a bag. This kind of form, this body form that looks like a plant, looks like a clump of grass growing up. Mm-hmm. which is super interesting. And I don't really know why it's taking that form right now. It's not grass. It's actually an animal. And in terms of benefits, I don't know of anything that eats it. It's kind of full of little, they're almost like glass bones is kind of their skeletal structure. They're called spicules. I don't think anything eats it. They're photosynthetic. They capture some of that stuff. So I don't know of any benefits or harm based on that, but it's certainly, there's not these dense beds of it that small bass or small fish would be hiding in. So it probably has no impact. It's just kind of a cool.
So we're not going to see mats of freshwater sponges.
I don't know that we will or we won't.
Yeah.
It'd be interesting if we did.
Yeah.
But no, it doesn't seem like they're definitely not going to be on the surface where you can throw a frog over it or make use of it in any kind of pattern.
Sure.
I didn't realize I was muted. Do you know of any harm or anything? Like if we do see an abundance of that, is that going to harm anything? Is that going to, I guess I don't really know the best question to ask, but
yeah, that's a good question. I don't know of any harm that it would cause. I don't know. I haven't seen any research on that where there's such an abundance that it starts to affect other things.
okay.
So kind of to wrap up the grass discussion here, will we see hydrilla and or milfoil again on Kentucky Lake?
I mean, that's a good question. We are seeing reduced numbers of grass carp over time. We have not seen any kind of successful reproduction in the system, either in the lakes or in the immediate tailwaters since 2015, although there are still reproducing fish in the Mississippi River system. So the Mississippi River proper, the Ohio River, that sort of thing. And those fish can swim into the lock chamber still. So we'll likely also or always have low numbers until there's some widespread control within the Mississippi River system. I suspect that as the lake continues to clear over time, which we've seen a trend throughout the lake's history of doing that, we'll probably end up with too much grass. That was certainly the fear back in the 80s and throughout time is we're going to have so much we won't be able to deal with it. And from a fisheries perspective, some grass is good. The rule of thumb generally is you want about 20% grass coverage in a reservoir. You get beyond 20% and it gets to the point where the bass and other species can't feed efficiently. So you've got all kinds of fry and forage that are in the grass. Bass can't get to them. So you end up actually hurting your bass population by having too much grass. And that's a very controversial statement, depending on what state you're in. Not so much around the lakes in my district, but Florida, that's a huge hot button issue where they try to control grass down there to try and improve access and the fish populations. And they just get hammered by anglers over that because they like fishing the grass patterns. And
Sure.
It's hard to blame them for that. But yeah, I suspect long-term Kentucky and Barkley, we're probably going to end up with too much vegetation, which would be that's a challenge because you can treat vegetation in, a small or water body with some herbicide. Treating something like Kentucky Lake, that's just impossibly expensive.
Sure. Well, and it almost seemed like we were potentially there or getting there when I first came here in 2013. I remember my freshman year of college. I've said this numerous times. It seemed like you could stand on the Paris Bridge at the top of the Paris Bridge and look south, and you could tell exactly where the river channel was and exactly where all the creek channels were, because that was the only place there wasn't any grass. Mm-hmm. All the flat areas were all matted grass. And so there was a lot of grass back then. Obviously in the bays and everything, there was a bunch of grass. So I guess it's having that balance. There is such a thing as too much grass, and obviously, there's such a thing as no grass like we currently have.
Yeah. And I would say the encouraging thing about having the no grass, at least in our lakes, is that the recruitment doesn't seem to be affected by it, at least not in any way that I can detect. So the fishing is still improving as we get good year classes, and the fishing is getting really good right now, and we don't have grass. So we can have a good fishery without it. Would it be fun to fish grass mats? Yeah, it would be. We may do that again at some point. I don't know that we're going to get there anytime in the immediate future.
Sure.
Even those grass carp.
I know what you just said there. That's a controversial thing, that saying that the lack of grass is not contributed to recruitment at all, because that's the biggest thing that I hear is, well, we need grass. Grass would fix everything. If we had grass, we wouldn't have any problems.
Mm-hmm.
And based on what you're finding, that's not necessarily the case.
And I want to be specific here. I'm saying I can't detect how it may have affected things. There likely would be some small effects because you do see those effects in other systems. It's also the case that we haven't lost our emergent vegetation. So our water willow, that grass that's along the banks, that's pretty abundant in a lot of places.
Absolutely.
It could be used for those fry to hide, live, grow up. And it's not like those small bass were moving offshore out in those grass mats. That's not where their habitat is. They're hanging more in that inshore area. So we still have vegetation, and that likely is still helping our recruitment. But those submerged grass mats, I can't seem to find a link between that and the number of bass that are produced each year.
Sure. So, and I know we kind of touched on the grass carp situation. Obviously, carp has been another hot topic over the last several years with the Asian carp as a whole. So what species are considered Asian carp?
Well, yeah, I like the way you worded that question. So there's basically 4 species that are here right now that are routinely called Asian carp, or the term now is invasive carp. They've switched that a little bit.
Sure.
So you've got silver carp, which are by far our most abundant. And they're the ones who most frequently jump out of the water whenever they're scared, nervous, or just want to jump out
randomly,
scare us. Yeah. Then you have bighead carp, which look very similar. They're larger. They have slight dietary differences between them and the silver carp. You have grass carp, which we talked about already, that feed on submerged aquatic vegetation. And then you have black carp, which are our most recent invader, and they feed on snails, mussels, mollusks in general. And you've also there is a common carp species, which has been here since the 1800s. And that's kind of native to Eurasia. And it was brought over here way back when as an additional food source because people like to eat them. They've been here so long, people have kind of forgotten that they're invasive. But
that's your yellow carp?
Yellow carp, yeah.
Mm-hmm. So with that, you said there was dietary differences between the silvers and the big heads. What is a carp diet? Because that's another thing that I've heard over the course of the years. I saw an Asian carp eat shad. I know I did. So what is their diet?
Yeah. So for the silver and the big head, they're both feeding on plankton. But because they evolved in the same ecosystem, same reservoirs, same lakes, rivers, whatever, they have slightly different dietary needs because no fish wants to compete with another species if it can avoid it. So they've shifted where they eat, where they can live alongside each other without too much competition. So the silver carp, well, first of all, there's 2 general types of plankton, phytoplankton and zooplankton. Phytoplankton are just small microscopic plants, just like grass or trees on land. These are small plants. They photosynthesis, all that stuff, chlorophyll, and they just float around. That's your phytoplankton. Then you have zooplankton, which are tiny microscopic animals who a lot of them feed on the phytoplankton, just like we have herbivores here that eat grass and leaves and whatnot. And then some of those are predatory. Some of them can do both. Some of them can take in chloroplasts and do photosynthesis themselves. It's a wild, wild world when you're talking about plankton. The silver carp feed on a mix of phytoplankton and zooplankton, although it tends to shift more towards phytoplankton, so more of those tiny plants. The bighead carp, on the other hand, feeds more on the zooplankton, although, again, they can feed on both. So they're mostly trying to find those really large microscopic animals and feed on those. So there's slight differences between the two, which make important differences when you're talking about their ecological impacts.
So I would assume, and please correct me if I'm wrong, you talked about the lake clearing. Does that contribute to that with them eating more plankton and everything like that?
Yeah, it probably does. And I say probably because it's a really complicated question to answer. So one of the things that we know based on research done by Murray States, so there's a research station, Hancock Biological Station. They've got long-term data collections going back to 1988 on Kentucky Lake. They'll go out and measure things like the plankton levels, the chlorophyll levels, a variety of, it's like 60 something parameters that they check every time they go out, and have done so since 88. And they've seen what we've seen, that the lake has gotten clearer over time. So reduced levels of chlorophyll in their sampling. So reduced primary productivity is what we call it, or reduced levels of phytoplankton over time. And that trend is kind of continued through time. And we don't know whether the silver carp have been contributing so much that it's causing a steeper decline in those. So it's kind of an unanswered question, and it's complicated. Obviously, they're feeding on phytoplankton, but they're also feeding on zooplankton. Zooplankton feed on phytoplankton. So if you have so much zooplankton, you'll have a reduction in phytoplankton. So you've got that complication. You also have the complication of a silver carp when it ingests certain phytoplankton, like a diatom, which is like it has a glass skeleton and just it photosynthesizes as well. It's kind of free floating. When it consumes those, it doesn't completely digest it. So when it excretes what it's eaten, what it is excreted is still viable and will kind of regenerate into plankton. And it also does something where it's, it basically transports nutrients from the phytoplankton in the water column down into the bottom of the lake, which can also stimulate a whole, different chemical cycle. So they almost certainly would have an effect in high enough numbers, but we don't know whether there is a level of plankton that is low enough overall to see those effects. Meaning, like, you got a field out here, there's grass growing in it all the time. If you had deer or cattle or whatever out there feeding on it, it's not necessarily the case that you're going to see a major reduction, because there's probably plenty of grass out there. But if you put enough cattle on there, then you'll get to that tipping point and you'll start to run out like, oh, we got bare ground out here. We got to move to a different pasture or something like that. Sure. And we don't know where we're at for Kentucky Lake in those terms. There was one year in 2017, and you may recall the lake got really clear in 2017.
Yeah.
The water clarity is typically like anywhere from 4 to 6 feet on average in its clearer times of the year. 2017, it was 16 feet of water clarity.
I remember in the fall, I was throwing an A-rig with white swim baits on it, and I sent it down in the water just to see how far I could see those white swim baits. And I estimated it at about 14 foot.
Yeah. And that's basically what scientists do as well. We have a round disc called a Secchi disc. And it's a black and white, different quadrants of it. You lower that down. It was actually invented by some Catholic priest because the Pope was curious about water clarity in the Mediterranean and wanted to have a standardized way to do it. And now that's done all over the world. But anyway, you lower that down and then you measure the distance of your rope, and 16 feet. So you're doing it the same way we do.
Sure.
And that was crazy. And the reason for that seems to be an effect of the zebra mussels, which were in the system in great abundance in 2017, as well as higher levels of silver and bighead carp.
So you said the zebra mussels were in the system in 2017. Were being past tense. Yeah.
So zebra mussels, again, are another invasive and what we would call a planktivore. So they feed on plankton, just like the silver and the bigheads. And they're an invasive species of essentially a freshwater mussel. And they've been in the lake since 1994. That's when they were first picked up. But they haven't been in very high numbers, with the exception of 2017. And it's thought, the research states that you need a certain level of dissolved calcium in the water for them to be able to make their shells to be an adequate thickness to survive. And the calcium levels in Kentucky Lake seem to be borderline or just below what they need to have this sustainable population of zebra mussels. But in 2017, they had this major reproductive event, and zebra mussels were everywhere, all over the bottom. Any kind of hard structure basically had zebra mussels on it. And like I said, they feed on that plankton. So they They suck it into one siphon, filter it, and push it out the other, just like a lot of our native mussel species. And so they really cleared up the water at that time. And that had some very noticeable effects on the fish populations. Shad numbers were very, very low that year. The relative weights, which is essentially a measure of how fat or skinny a fish is, relative weights dropped dramatically in 2017 for bass and crappie, which is what we measure. Now, they weren't the lowest all time. We had several years in the lake's history because we have 40 years of data. We have several years where the relative weights were lower than that. So it wasn't unprecedented, but it was still very concerning to see a drop like that. And thankfully, the next year, zebra mussels were back to their kind of baseline levels. We still pick up some adults here and there, particularly in areas where calcium is leaching out of, say, concrete products or limestone, that sort of thing. So places that are rip-wrapped, places that have concrete structures, you see a higher density, but not to the level where we're seeing this vast clearing of the reservoir.
So you said you still pick up some adult zebra mussels. What's considered an adult? What's their lifespan, I guess you could say? I
don't know what their lifespan is. And you do see, I looked this year because Michael Flynn, who's with Murray State University, he was asking me, like, I was noticing him on some of our concrete structures when I was snorkeling. And then finally pieced together, it's because they're concrete structures. They're leaching calcium. And there are different age classes on there. They'll start off, the size of, your pinky nail, something like that, will be kind of a 1-year-old. And then your biggest adult is maybe size of your thumb, something like that. Maybe not quite that long. Depends on your thumb, I suppose. But I don't know what their total lifespan is. I suspect it's pretty long. Most mussel species can live for a long time.
So one thing that you kind of touched on there was that year that we had a lot of zebra mussels, they were also competing for that plankton. We saw a reduction in the shad population.
Yeah.
So with the Asian carp or the silvers and begheads feeding on that plankton, we've seen an increase in the baitfish population, but are we at risk for that going forward with our population where it is with the Asian carp?
So that is my biggest concern when it comes to silver and bighead carp is the impacts on the shad population. It's very common to see on state's website, including on our own website, that silver and bighead carp feed on plankton. Our native species also feed on plankton, so there's potential for competition there. And that's true. Those words are true, but that's like the most simple way of explaining it to the point where it's lost all meaning. Plankton, as we already discussed, is kind of a complicated system. It's its own, a whole bunch of different species of phytoplankton, a whole bunch of different species of zooplankton, some predatory, some herbivorous, it's complicated. And to say all plankton are the same is a bit of a disservice to the plankton community. I'm not worried about their feelings, but you have inshore and offshore plankton, and those communities are different. And a lot of factors go into that. And then obviously all of our native species have their own ecological, what we call a niche. So a place in the environment, things that they feed on that other fish don't feed on. If they all fed on the exact same kind of plankton at the exact same time, then competition is inevitable, as long as it's a limiting resource. Because that's what you need to say that there's competition. You have to have two different groups of animals, or two animals in general, using the same resource at the same time, and that resource has to be limited. So the three of us in this room, we're all humans, kind of on the same trophic level. We all consume oxygen. But I wouldn't say that we are competing for oxygen in this room, because it's not a sealed room.
Right.
If this was a mine shaft that had collapsed, then maybe we start making some tough decisions. But
Donovan's
for the moment, we're not competing. And you don't really, it's hard to calculate all those factors within a lake to say what is competition and what isn't. What we do know is that the dietary overlap. So when you compare the diets of bass and the diets of silver carp, there's essentially no overlap. Bass are feeding on small fish. Silver carp are never feeding on small fish. And even on the very small level, like a larval bass, it is feeding on zooplankton, but it's not feeding on phytoplankton. So there's already a little difference in the diet there. More so, that little larval bass is feeding on inshore zooplankton. The silver carp that are adults are feeding on offshore zooplankton. Totally different communities. So the idea that there's competition between those two species is very unlikely because they're not feeding on the same resource at the same time. And we still don't know whether it's a limited resource. But when it comes to things like gizzard shad, we know that the dietary overlap between a gizzard shad and a silver carp is nearly identical. So there's a strong possibility for competition if there is a limitation on the amount of plankton that they're feeding on. And we still don't know if that's the case. But that probably was the case in 2017 because you had zebra mussels feeding on some of it. Then you have shad feeding on the same thing as silver carp. So you're going to see competitive effects between those two. And you definitely did. And I've been talking for a while here, but I'm going to keep going.
Absolutely.
The effects of competition can be defined as a negative outcome for both animals. So again, if we're in a mine shaft competing for oxygen, we're all struggling. That's the competition. We're using that resource and it's negative for all of us. It'd be a lot better if you could breathe nitrogen and I could breathe oxygen. So when communities are stable for a long time, they kind of evolve to separate out what they're feeding on and have that difference. But whether that can happen rapidly is something that's still up for debate. So the idea that, gizzard shad can compete with silver carp is still very much a strong possibility. And that's the thing I worry about in the future. If carp numbers go up, or if zebra mussels come back in strong numbers, or if we see a major decline in the productivity of the lake. So big drops in the levels of plankton. And let me expound a little bit more. When you talk about native, sport fish possibly competing with silver carp, it's possible. It's unlikely in my opinion. And the reason goes back to what I said earlier. They have the same dietary overlap or diet as a gizzard shad. Silver carp are basically a big gizzard shad in ecological terms. Well, gizzard shad have been around for forever in these systems. And they have been sharing resources with bass, crappie, bluegill, whatever, for a long time. And they've likely set up a system where they're not feeding on those same resources because they're trying to avoid that competition. So it seems unlikely to me that silver carp are suddenly going to be using those same resources as all those other fish, because it just doesn't make any ecological sense for them to want to compete at every feeding position in the water.
So it seems like, we've had Asian carp for a longer period of time than the zebra mussels, for instance, at a higher population. So it seems like from what you've said is the zebra mussels played a large factor in that decrease in shad.
In 2017, for sure they did. And you also saw, and I skipped over this a second ago, you saw negative impacts on the silver carp population. If you recall in 2017, that was when we had a major die-off of silver carp.
Yep.
And people were calling them suicide carp.
Yep.
Because they were beaching themselves. They were jumping up on the shore and killing themselves, committing suicide, basically.
Sitting there swimming in circles.
Yeah.
Yep.
And the best theory we have about why that was occurring, and of course we send those fish off for testing, and they kind of came back for just ordinary bacterial infections, nothing like a virus. And there were rumors that we had released a virus into the lake that killed them. I was like, wow, you're giving us a lot of credit for being able to invent a virus that does that, and not a lot of credit for we just did that. We didn't tell anybody.
Yeah.
We thought we'd kill them and not take any credit. And we thought we tested in this lake that you all use.
In 2017, if you would have found something that would kill Asian carp, you would have been put up on a pedestal.
Yeah.
Like you would have been a hero.
There was somebody was offering like $1 million reward for the best solution. And obviously we didn't apply. We didn't do that. What that was, at least as near as we can tell, was the competition for plankton at that time was so intense that it reduced the health of that population of silver carp so much that they became susceptible to ordinary infections. And you see that in any population. If there was a famine here, a lot of people would get sick and die. They wouldn't necessarily die of starvation. And it seemed to be that those bacterial infections were actually affecting the brain of those fish, which is why you saw that beaching behavior and the erratic swimming and that sort of thing.
So with that being said, why were most of those fish around the 2 pound range? You know, it seemed like a lot of them were the smaller ones. We didn't see the 30-pound fish jumping up on the bank near as much as we saw the smaller fish.
Yeah, that's a really good question. And at this point, there doesn't seem to be much strong evidence anyway that the diet of a 30-pound fish is different than the diet of a 2-pound fish. So the best explanation for that, in my opinion, is that there were a lot of 2-pound fish, because that was the 2015 year class when we had that massive reproductive event. So all the fish were exactly the same size and same age, all brothers and sisters, for lack of a better concept, maybe cousins probably. But so yeah, they were all the same age, and they were just so abundant they outclassed everything else.
So I remember it's been a couple of years listening to you talk about the Asian carp and that event that happened where all those smaller fish, and you had a graph that showed the life cycle of an Asian carp. And there was something along the lines it's been a couple of years, so it may be incorrect, but there's something along the lines of like 90% of the spawn class in year 2 died. Is that correct? Or something along those lines?
Well, you get a lot of questions like, how long does a silver carp live, or how long does a bass live?
Yep.
The best answer, well, I don't know if it's the best, the most technical answer to that is, not long at all. Like, they die as eggs.
Yeah.
That's what the average one does.
Sure.
And that's more the case with silver carp than it is with other species. So the silver carp life cycle, what they do to reproduce is they'll get into an area which has high flows. They evolved in big rivers with high flows, and that's what they seek out. So the males and the females will all get together in a big group. The females will release eggs. The males will release sperm, which will fertilize those eggs within the water column. So they're not making a bed like a lot of our native sport fish species. They're just in the water column. Then those eggs, once fertilized, they'll actually expand a little bit to get a little bit larger, and they become semi-buoyant, meaning they don't float all the way to the surface. That would probably be a bad strategy, because then anything that saw it would just scoop down and take as many as you want. But they are semi-buoyant in that they sink very, very slowly at a rate for silver carp of around, I think it's 0.73 centimeters per minute. So they sink very slowly. And if you do that reproductive event, like in still water, it'll just sink to the bottom slowly, get covered in sediment, and it'll never hatch. So what they need is that sustained flow for a long time to keep those eggs suspended. Now, it depends on water temperature as far as that incubation period and how long they have to stay suspended. But it's thought they need to stay suspended for 2 or 3 days under most conditions. So you got to have a long stretch of river that's relatively turbulent with high flow to be able to make that happen. Now, once those eggs hatch, they're kind of on their own, and you see what we assume is really high mortality rates during that first year. That's very common for all fish species. Mortality rates don't really stabilize until after their first winter, the first year, for a lot of fish. And for silver carp and bighead and all those Asian carp species, there's no parental care. It's not like a bass is guarding that nest for a while. Once they release the eggs,
they're gone.
It's whatever you're on your own, son. See you later. So there's no parental care at all. And that's why, in fact, they have a whole bunch of eggs. And you hear people going, they have 1 million eggs per fish, which they could have 1 million eggs per female. They can actually have more than 2 million for a really large female. The average female has about 250,000, which is a lot of eggs. And it sounds like, every fish can multiply itself times 250,000. And all of a sudden that's the only animal left.
Yeah.
Clearly that's not the case, because a lot of those die. And the reason they have so many eggs is because they have no parental care. With a species that has more parental care, like a smallmouth bass, much lower numbers of eggs, because they're protecting them for a lot longer. They're also bigger eggs, so that they're smaller. So it's that ecological trade-off that those species have evolved to exploit.
So the Asian carp consistently spawn in our lakes, just not successfully.
Yes. Yeah. Definitely. They produce eggs each year, sperm each year.
Do they only spawn once a year per fish, or is there a spawning season for them, or is it just free for all throughout the year.
There is a spawning season. It has to do with temperature, and flow conditions also seem to be pretty important, where if you get a massive rain event, higher flows, then they'll all kind of congregate, and that's a cue for them to start spawning. But water temps also have to be pretty warm.
So I remember back in 2015, I believe that was a year of high water in the spring, and there's a lot of current. And so that's, if I'm understanding correctly, that is probably why we had that spawn, that successful spawn, was because we had a lot of high water, a lot of water moving through the system.
That is the best theory. That's what's been established everywhere else, is that you need those high flows. And of course, we don't have consistent flows like that in the reservoir. Furthermore, yes, they do try to spawn every year. We see evidence of that in dropping egg weights over time, which you can monitor by looking at fish which come into the markets. But yeah, it hasn't been successful any other year than 2015. Furthermore, in 2015, we don't know whether they spawned successfully in the reservoirs or in the tailwaters below and then swam into the lock chambers.
Now, obviously, with that being said, there's going to be a lot of people that are going to say, well, we've got all these fish. Like, obviously, they had to spawn in the lake. How many fish come through the locks? Do we have any idea?
They probably have a really good idea, because they've been doing that experiment at Barkley Lock with that deterrent that's in place down there. So they probably know with some pretty high accuracy how many can swim into the system. I don't know what that number is, but I know it's a lot. Like I said, we tested those fish in 2015. You can take the otoliths, which are the ear bones out of fish, and they have the otoliths as soon as they're hatched. And then they add a little bit of growth on the outside of it each day. So if you were to crack it open and look at the center of it is the oldest part, and the outside of it is the youngest part. Well, you can take that otolith and you can use a process where you look at the isotopes within that otolith. Use something called laser ablation. And you essentially look at the chemical signature in the center of it. And you could say, okay, it was in water with this type of chemistry whenever it was hatched. And now it's in water with this type of chemistry. So we compared that with, let's say, water samples from the lakes and water samples from the tailwaters to see, okay, where was this fish hatched? Unfortunately, there's not enough difference in the water in the reservoir versus the water in the tailwater to see a difference in the chemical signature. So it was inconclusive. And when we picked them up in the reservoir, they were already at least 1.5 inches long, which puts them, probably at least 3 to 4 weeks old.
So the youngest Asian carp that you found in the lake has been 3 to 4 months old?
No. 3 to 4
3 to 4 weeks.
weeks.
I'm sorry.
Yeah.
Yeah. So the youngest Asian carp that you have picked up in the lake has been 3 to 4 weeks.
Basically, yeah. I'm guesstimating
over the course of time.
Yeah. We haven't seen any evidence of even young of the year fish in any year other than that 2015 year class.
Now, what about in the tailwaters? Have you picked up fish that were younger than that?
Yeah. There was a year prior to that, 2010. There was a recruitment event observed in the tailwaters. Lots and lots of little silver carp. And then 2019, there's a guy down there, and you may know him, Jim Doom. Yeah. Jim picked up some in a cast net in 2019. And it was just, from what he told us, it was just one school. We went down there and sampled extensively after that, could never find any. 2015, conversely, the shoreline was black with silver and bighead carp along the edge, grass carp as well. So we went down there and you could collect thousands of those easily, just scoop them up. I went down there just fishing one day with some friends that also worked for the department at the time. And you could just take a dip net and scoop up as many samples as you wanted.
Sure.
And that's what we did to get a lot of them. So we haven't seen that in any other year since then. That doesn't mean that there isn't a small amount of successful reproduction that occurs that we haven't been able to detect.
Sure. Of course.
So I can't say they definitely didn't.
Yeah.
But not to the level that we saw in that 2015.
Sure. So what is it that we can do, or is there anything that we can do to try and prevent 2015 spawn from happening and the 2017 zebra mussel outbreak from happening?
Yeah.
Because that seems like two really big factors over the course of the last several years.
Yeah, things you would want to avoid.
Yeah.
preventing the 2015 scenario of a silver carp and big head spawn and grass carp spawn for that matter, that's been discussed quite a bit. And a lot of people, rightly so, make the connection that if it's high flows that are the problem, why not just stop having high flows during that time period? Which, it's a good solution in theory. The problem is in the scenarios where you have high flows like that in the summertime, it's due to excessive amounts of rainfall and flooding. So it's not a scenario where you can just not release water. So it's the times when you would want to control it are the times when you'd have the least control. So that's probably not a viable solution.
Mm-hmm.
To prevent that in general, we have been obviously promoting and subsidizing the commercial carp fishery in Kentucky Lake and Lake Barkley, and promoting it across the state of Kentucky for many, many years. Since there was some early work going on back to probably 2008 or so, but it's been subsidized since I think 2013 or 14. That's when the program began. And it's really been quite successful, I think.
How many pounds were caught last year?
I think it was 13 million pounds.
That's quite a few.
It's a lot. And the number of fish declined, but because they're bigger, you ended up with more and more pounds.
Sure.
And the pounds that have been removed have increased basically every year since the program began. There was one year where it dipped, and that was more due to market fluctuations. We had a processor that went out of business, and that slowed things down, but it's gone up and up over time. We also have the barrier/deterrent that's being tested below Barkley Lock. And that is a hydroacoustic fish fence. So we know that the vast majority of those carp have swam into the reservoirs through the lock chambers from the lower rivers, where there are reproducing populations in the Mississippi and Ohio. So if we can prevent them from swimming into the lock chambers, you can stop them from getting into Kentucky and Barkley. And I mean, that's a brilliant solution if you can pull it off.
Sure.
And to do that, the initial testing has been with that hydroacoustic barrier, which is a row of underwater speakers, as well as lights and bubble emitters. And it's all in a line, basically a wall below the entrance to the lock chamber at Barkley Lock. And when it's on, they've done testing. It was ended up being a 4-year test, I think. But it seems to reduce the amount of carp entering the lock chamber by 50% whenever it's turned on, which it's not 100%.
Sure.
Which is why it's a deterrent rather than a wall. But a 50% reduction is,
it's
a decent result, in my opinion. It's worth continuing.
Sure.
And there are plans to add those in other locks throughout the system, as well as, modify that technology.
So with that, you said when it is on, it's 50% effective.
Mm-hmm. Yeah.
Well, in my head, why would you ever turn the thing off?
That's a decent question and good catch. So during the testing phase, they turned it off and on repeatedly. So they would turn it on for a week and off for a week. And they did that for years. And the reason for that is you wanted to take the seasonal movements and the environmental conditions out of the equation. So it could be if you left it on, in the springtime and turned it off in the summer, you're not really going to learn very much. You might just learn, well, there's a lot moving in the spring and not in the summer.
Sure.
So they had to fluctuate those things over time, which is how they can make that comparison.
People can drive through that while it's on. Barge traffic doesn't slow down. They don't have to turn it off for barges or commercial or recreational traffic going through the locks.
Correct. I haven't ever, stuck my head underwater to see what it sounds like.
Sure.
But it just plays a proprietary sound blend that was developed by a company out of the UK. And they're the ones who made that technology. And it should be perfectly safe for anybody to go through on a boat. It certainly doesn't slow down barge traffic. There are electrical barriers that are in place in some areas in the north around Chicago. And those do pose a safety concern, although I don't think they turn them off whenever the barges go through, because that's when they're going to be pushing fish.
Sure.
So it's a better solution in that sense. And even if it isn't 100% effective, like it's 50%, the basic plan is still to prevent them from swimming into the lock chambers. So whether it's that barrier technology or the next generation, the plan will probably remain the same to isolate their movements.
Well, I think that we touched a lot of stuff there with the grass and the Asian carp and that. Now on to a little bit more fun stuff, I think. Talking about the bass population, one thing that I've heard you discuss multiple times is the reason or a large reason why our bass population went down in Kentucky Lake was because we had inconsistent recruitment over several years. Why did we have that inconsistent recruitment?
Yeah.
What are the contributing factors to that?
Yeah, that's a really good question, because that's kind of what we've been working on for really, there was research on it going back in the late 80s, and it's kind of continued and really intensified whenever the lake went downhill, several years ago. It's like, well, we know the problem is recruitment. How do we increase it? And it's not an easy thing to even understand, and much less solve. So it's been challenging to do so. We know that environmental factors play a strong role, but in the past, it's always been looking at seasonal variables. So the amount of rainfall in the spring or the summer, or things like that, the water clarity, water levels on big grand scales, because you only get one data point per year where you're looking at, here's the recruitment level. Here's how many young fish were produced. And you compare that to other years. So it's not a really high resolution analysis. And what we've done in recent years is try and do a higher resolution analysis, where instead of just looking at the total number of fish produced in a given year, we're looking at the timing of that reproduction. And we're doing that in multiple ways, but the primary way is we're looking at hatch dates. So we go out and collect fish, and my guys were out doing it 2 days ago in several embayments. You collect fish right now, this time of year, bass, and then you can remove their otoliths, those two small ear bones, which again, the oldest part's in the center, puts on new growth each day. And you can actually take those, put them on a microscope slide, polish them, and then you can count rings on them. And those rings represent days. So you can know when that fish hatched, which is really interesting information.
Mm-hmm.
It takes a really long time, and it's exceedingly boring. Usually put on a few podcasts for that one. But you can glean information from that about, okay, what did the spawn look like? What day or what week were they hatching on this year, and what were the conditions like? And then you can compare that over years and go, what happened in this year that made it so good? What happened in this year that made it so bad? And there's still a lot of unanswered questions. One of the theories that I like the best and seems to be supported pretty well by the data is the impact of temperature, water temperature specifically, which is of course affected by air temperature. And one of the things that we know about bass recruitment in these reservoirs is that the earlier a bass spawns, the more likely it is that those fry and young of year fish will be large enough in the fall to survive their first winter. So you often see a distribution of fish when we sample in the fall of, like, some of them are 6 inches long, some of them are 2 inches long. And when you look the following spring, those 2-inch fish didn't make it. 6-inch fish did. And the best research shows that it's that early hatch date which leads to that faster growth, because it puts them in a positive feedback loop. What do I mean by that? Well, when you hatch early, let's say we have a bass that hatches on March 15th, which would be pretty early for our lakes. Well, it starts feeding on plankton, and it does that for a week or maybe two, gets a little bit larger. Then maybe it eats some aquatic insects, that sort of thing. Well, by the time the bluegill or shad spawn occurs in, say, late April, early May, that bass is already big enough to start eating those fry that are hatched. So it can take advantage of them very quickly. And that's the best thing that can happen if you're a young bass. You want to be eating other fish, because that gets you the most calories and the right ratios to grow more fish flesh, which is what they're made of.
Sure.
So that's the goal, is to start feeding on fish as quickly as possible. And if you hatch earlier, you're likely to do so. And it's a positive feedback loop, because if they are able to feed on those first fish, they grow at a faster rate. And they can constantly stay ahead of those bluegill and shad, because they're getting bigger throughout the year too. Now, conversely, you have fish that get caught in that negative feedback loop. Let's say they hatch on, May 20th, pretty late for us. Well, they're out there and they're about the same size as those fry that just hatched from the bluegill and the shad. So they can't eat them yet. So they try and catch up, but in a lot of cases, they never catch up. So when the fall comes around, they're the same size as the shad fry. Never got to taste any fish, and they're going to die that winter.
Sure.
So there's a lot of things that go into when a fish spawns and when its fry are hatched. One of them being that larger females and larger males tend to spawn earlier. So in one sense, and some authors have suggested this in the past, is you need to protect big fish because they're spawning earlier, going to hatch earlier, better recruitment. And that's possible as well. One of the things that we've seen is that in years where it warms up earlier, you get an earlier bass spawn. And you also have seems to be a factor where there's a temperature range for bass to spawn and then a temperature range for bluegill to spawn. And there's some overlap, but there's also differences. The bluegill aren't spawning whenever it's 60 degrees. Bass are. So if you have a year where the temperatures stay in that like 57 to 65-ish range for a long time, that starts you off with an earlier bass spawn and delays the bluegill spawn. So you get more fish caught up in that positive feedback loop. So that's kind of what we've been looking at as the primary reason. And in those years where we had poor spawns, we had either cold springs or springs where it warmed up rapidly. So it didn't warm up early, warmed up late, but very quickly, like, just 2 weeks kind of in that zone versus a 30 or 40 day window.
So, it seems like timing is a big thing from what you found. The earlier, the better. Now, earlier this year, you were talking about your findings over the last few years with the difference in the largemouth and smallmouth spawns. And everything we've ever been taught is smallmouth spawn before largemouth. And it seems like that was the case 1 year out of a 3-year study that you were doing. 1 year they spawned at the same time. And 1 year the smallmouth spawned later than the largemouth.
Yeah.
Why did that happen? Do you have any thoughts on that?
No.
Can't explain that one?
I don't know why. And I'd really like to, because one of the things that, anglers and we've noticed as well is that the smallmouth recruitment was really high for several years recently. And a lot of the fish being weighed in are brown fish.
Yep.
I don't know why that is. We obviously observed elevated levels of recruitment for those species, but why we suddenly had good recruitment for smallmouth, I don't know. And it was a trend that we saw again in the late 90s when we had that downturn of the population in general. Everybody was all angry and upset then. And then something about, I don't know if it's the anger from the anglers or no, it's clearly an environmental condition that leads to better smallmouth recruitment, but I don't know what that is.
Could it be less competition for bait?
I don't know. It could be multiple things. My best guess is it has something to do with slight differences in timing of the spawn. But, and I don't know for sure yet. That's one of the reasons why we collect those otoliths from smallmouth and largemouth. And I think we're in it's either 4th or 5th year of doing that. Of course, we don't have data going back to 1988 for that. If we did, we could probably answer that question. But at this point, we're kind of, okay, we got to figure out what's going on. And it's not that pressing of a concern. I'd like to know why the smallmouth recruitment was better.
Yeah.
But I'm not upset about it. It's not a problem I'm trying to solve.
Sure.
It's just I'd like to know in
curiosity.
Case we need to recreate it or whatever we could do.
So, we talked about light penetration and, there has to be a certain amount of light penetration for spawning activity to succeed, correct?
So the cues for a fish to spawn, a bass to spawn, or that whole family are basically driven by the sunlight levels. So the amount of daylight in a given day. A bass knows what day of the year it is based on that light period. That's why you don't see spawns typically in the fall or in the summer or something like that. They know springtime, I got to spawn early. I got to get my fry to survive. That's what they base it on. Water temperature also affects that. And the basic idea is that those light waves and particles penetrate the eye and hit certain cells in the bottom of that fish's eyeball. Humans have some similar cells as well that sets our circadian rhythms, among other things. And the light hitting those cells triggers the production of certain hormones. So it travels from the pituitary gland and goes to those reproductive organs and says, It's time to go ripen these eggs, get the sperm ready, whatever you need. It's that time of year. And higher levels of water temperature within a certain range seem to increase the impacts of those hormones on those reproductive organs. But it's also the case that if it's too warm, they'll give up as well. They're not going to spawn in July when the water temperature, 84 or 85. There's a certain temperature range. So those two factors play into when that bass is going to spawn.
More so than the moon phase?
But in my opinion, there is no research which says the moon phase has anything to do with the timing of the bass spawn. This one's even more controversial. The bluegill spawn, the red ear spawn, the crappie spawn, or the spawn of any fish that's swimming in Kentucky Lake or Lake Barkley. That doesn't mean that couldn't be the case. That just means that research has not shown that to be the case yet. That's certainly the anecdotal opinion. We're going to get 2 bluegill spawns this year because there's 2 full moons in certain temperature range.
Sure.
I probably have enough data to look at that analysis because I do the hatch dates and I do the snorkel surveys and all that stuff. I suspect there's not a pattern because of the importance of getting your fry out there earlier, probably overweighing the idea of that we're in a waxing gibbous or whatever it is. And they're looking up and that's probably not something that factors into it greatly that would overpower just daylight period and the water temperatures.
So speaking again on the light penetration, does there have to be a certain amount of light penetration on the eggs after they have been spawned?
No, the light penetration
is only for getting everything going.
That's for stimulating those hormones so the fish know when to spawn. I don't know their effects on eggs. I suspect they would be negative and that you'd be getting UV radiation onto the eggs. So that may be a reason for making your nest deeper than shallower, although other factors probably do.
So could a fish technically spawn in 20 foot of water?
Technically, yes. There's a few other factors at play there in that the water temperature is going to affect the incubation period needed for those eggs to hatch. So let's say you've got two bass nests. One which was made in shallow water on March 15th. The other made in 20 feet of water on March 15th. It's very likely that the eggs in the one in shallow water are going to hatch earlier because the water's going to warm up on those sunny days. And we see that. I go out and collect eggs off of beds. And sometimes you'll collect those eggs, and by the time you get them back to the lab to take a picture of them, they've already hatched because they've been out kind of in the air for a while, and they're just warming up. So there's a trade-off there. And you also end up with, if your eggs take too long to hatch, they're more susceptible to fungal infections. So you kind of want that happy medium because obviously if you're in shallow water, you're at more risk of getting dewatered or taken out by some kind of bird predator, sight fished by an angler.
Sure.
In some sense, it would be safer in 20 feet of water, but there are other complications.
They're going to have to wait longer to spawn, which is then going to make it less successful of a spawn because they're going to be later in the year.
I mean, they could spawn then, but yeah, their eggs are going to take longer to hatch.
Yeah.
And then they have to sit there and I can't imagine how stressful that is for a male bass to sit there and guard against bluegill.
Sure.
For 3 weeks.
Yeah.
I mean,
take a lot out of you.
Head on a swivel.
Yeah.
He's behind me. Oh, yeah. It's got to be rough.
It did seem like, now, especially with forward-facing sonar, we're learning a lot more about the smallmouth spawn and the spawning that happens out in the middle of the lake. It used to be the thought was every bass in the whole entire lake goes to the back of the bay, spawns, follows the creek channel out all the way windy, and then they go out to the river channel, and that's where they spend the summer. And it seems like the more time goes on and with electronics and everything, we're learning that is not the case. And you may have already known that, the whole entire time. But, this year, the Tackle Warehouse Invitational Tournament was here middle of April. A lot of spawning smallmouth caught in the middle of the lake on stumps and, on the flats and everything like that. Well, we saw a lot of those fish being caught in that 6 to 12 foot range. And so, again, everything that we've been taught, 12 foot's pretty deep for this lake, I would think, for a spawning activity. So that's where that kind of came up is we're seeing now, because our electronics are so much better, those fish that are spawning in deeper water, which goes against everything we've ever known. So that's just been interesting to see. I've been interested to know what are the benefits of being deeper versus shallower. And I think you kind of touched on that there. So with that, what are we, and I say we, what are you and your team doing? What is the state doing to improve the recruitment?
Mm-hmm. Well, when you talk about temperature being one of the factors, unfortunately, that's not something we can control, at least not easily. Theoretically, you could have big, shade tarps over something or water heaters or whatever it could be, but that's not a very practical solution. So it's not something we can change. So one of the ways, and really the only way we've come up with to try and improve things, is through increasing the available spawning habitat. So it's also the case that the conditions could be right from a temperature and sunlight perspective, but if you have two bass and you got them in a clear aquarium with nothing in the bottom except glass, they're not going to spawn in the corner. They have to have some type of structure cover for them to spawn next to or inside of or whatever, what have you. And it's possible that in our reservoirs, there's a limitation on that, at least to the point of not all fish can spawn whenever they want to. That's a theory. We know that the largest fish spawn first and the smallest fish spawn after that. We don't know why that is the case. It could be because of differences in the hormone levels and just what they could do, something physiological. It could also be the case that there is competition for spawning space, and those bigger fish win that competition. And those smaller fish are left waiting out there offshore until they can find a spot. So that's possible. If that is the case, it may be possible to increase the available spawning sites so that more fish can spawn earlier. And that's what we've been trying to do. And we've done that by adding some laydowns. So we'll cut trees off the shoreline, and then we'll take them and attach them on the top of two 12-inch concrete blocks with wire. So that tree is somewhat suspended. And fish will often spawn next to those. We've also made some concrete spawning beds, which are about 30, 32 inches in diameter. They're bowl-shaped. They're about 10 to 11 inches tall on the outside. And they're solid concrete, and they have a solid bottom. And then we also place loose gravel on top of that. So it simulates kind of a ready-made bed where they don't have to do much other than clear the sediment off the top of it. And then they've got sides to kind of offer a little bit more protection from sedimentation and other predators. And so we've been testing that in several bays. We've added probably, I think, a little south of 1,000 of those concrete spawning beds, and probably, I think it's 1,600 or 1,700 of the laydowns, which is not enough to have a major impact on the recruitment in the reservoirs yet, if it will at all. So the rebound that we've seen and those really high levels of reproduction, we can't attribute that to what we've done, although there may have been some improvement in some areas. But we're still experimenting with that idea, which is good that we have time to experiment and get it right now, because fishing is improving, the recruitment's getting higher on its own. So we can slow down. We don't have to do anything drastic. And we've been evaluating how well those structures are working. The primary way is we have a test bay set up where we have either a concrete spawning bed by itself, a laydown by itself, or a combination of those two structures. And they're spaced every 30 feet along a transect of shoreline. And then I will snorkel along that shoreline every week during the spawn. And I've done that for, I think this was the 5th year, to see, okay, is a bass using that to spawn, or what is going on there? And what we know is that within a given year, a given spawning season, about 50% of those structures will be used at least once by spawning bass, meaning they contain either eggs or fry. So they've been used, and basically successfully. We also see sunfish move in after that because they have that different temperature regime that they need. So once the bass are done, you see red ear, then bluegill, then long ear. usually in that order, all using those structures at a much higher rate. They're about 88% usage. So it's been successful in that regard, but we still don't know for sure whether that is actually increasing recruitment of bass in those areas. We just know that they're using it. It could be the case that those bass were already going to spawn, 5 feet away from our thing.
Sure.
And now we concentrated them and put them there.
Sure. So I've noticed a lot of those structures on Kentucky and Barkley. And to my knowledge, they've only been on the LBL side of both lakes. Is there any chance to do that on the residential sides of the lakes? Is there a limit there that you can't do that because of obviously homeowners and everything like that? What are the thoughts there because I would imagine that if a fish spawns on the LBL side of the lake, it probably isn't going to live later in the year on the residential side of the lake, although I'm sure it's possible for that fish to swim over there. I just wouldn't figure it's highly probable.
Yeah. I'm sure they get moved around, and we don't think about them as being separate populations as far as LBL shoreline versus residential. But the reason we picked the LBL shoreline was there's a few reasons for that. And we did primarily most of our work on Barkley instead of Kentucky. And that is because the spawns on Barkley over that time period, and really since then, have been lower than the ones on Kentucky. So that was where we wanted to hit, the squeakiest wheel. It's logistically a lot easier to do it on the LBL shoreline in that you can cut trees directly off the shoreline. We have permits to do so, and there are trees all over the shoreline. The whole thing's forested. Yep. So there's no point where we're like, I can't find a tree. Yeah. They're there. That's not the case on the residential side. There are some areas where we can do that, but I don't want to cut trees out of people's yards, and it's logistically more difficult to cut a tree somewhere else and bring it over there rather than dragging it straight down the shoreline.
Sure.
The concrete spawning beds, those could go basically anywhere, although there probably are a few instances where a landowner might be upset about a fishing structure going in front of their dock.
Where they swim or whatever.
Yeah. And it's, these things are only 10 inches tall, and they are solid concrete, but if 10 inches was all that was saving you from hitting the bottom or whatever, then you were making a bad decision anyway about whether to dive in or not. And there's also another reason why we picked the LBL shoreline, and that has to do with the potential. This is a extra controversial topic. The potential for a spawning area seasonal closure. So where you would close off parts of the lake to fishing during the bass spawn in the hopes that that would increase the recruitment. We have not pulled the trigger on that or really even suggested it very much, and recruitment levels have returned to above average. So there's no real reason to do it right now other than, if we want to do something interesting, if we want to try that, anglers want to do it, that's something you could try. And that would be a lot easier to try on the LBL side.
So similar to the wildlife refuges that are closed off from, October to April or November to April?
It's usually November to either March or February.
Okay.
It depends. It's complicated.
Sure. So something similar to that where there'd be buoys halfway back in a bay or something along those lines, and you're not to go back beyond that.
Yeah, that's probably what we would do if we were going to do it. And we would either make it where it is like a set time period, March 15th to April 15th or something like that, probably a 30-day window. Or we would just leave it completely kind of open-ended and say this is a voluntary closure, which I think is better anyway. That way no one can really say, you can't tell me where I can't fish. Well, sure. I'm not telling you where you can't fish. I'm just suggesting.
Asking you not to.
Yeah, asking you not to. You don't have to.
Yeah.
It's you're not going to get a ticket for it, which I think is ideal as well from it.
Sure.
Game wardens are stretched thin as it is, and there's no point in giving somebody a ticket for that.
Yeah.
It's their lake too. And if we did it voluntarily, we wouldn't have to have a set date because the regulation itself wouldn't have to be strictly enforced, as it were. So we could literally look at the water temperatures that year and go, okay, stop fishing right now over there. And we'll tell you when you can start again. And that would get interesting. Particularly, you can imagine what it's going to look like if for somebody fishing a tournament during that time period where you're going to have potentially conflicts with people. I saw you in Smith Bay or whatever.
Yep.
And, Fish and Wildlife says they don't want you over there. We're trying to do a voluntary closure to help the lake out. What were you doing in there? Is that how you got your 5 fish kind of thing?
Yeah.
And then also if you close it until April 15th, what happens at midnight, when everybody rolls in there?
Yeah.
Because the fishing is going to be bananas. They haven't been touched in a month.
Sure.
So it's something that would be the problem with even testing that idea is that I couldn't say for sure that it's going to increase recruitment. There's a lot of unknowns about whether that would work. And you really only see those things employed in the northern states, Canadian border, that area for smallmouth.
Yep.
And there's really good biological reasons why they don't do it in places like Florida, but it's less clear whether we should do it in a place like Kentucky Lake, which is kind of middle latitude and doesn't suffer from excess recruitment. So recruitment,
Sure.
We would want it to be higher. So my gut feeling is that we would get higher recruitment if we were to do that, but it comes with a trade-off in that you can't fish the spawn in those areas. And is that worth it? I don't know the answer to that myself.
Sure.
It's fun to flip bushes.
Exactly.
And you wouldn't be able to do it in that location anyway.
So speaking on that, there is lakes that there can be an excess of recruitment. There's a carrying capacity essentially to a lake. Obviously there is a carrying capacity to Kentucky Lake. Could we ever get to that carrying capacity though?
Yeah.
Is that such a thing?
I'm sure that we could. To my knowledge, we haven't. And there's been a study that took place in Alabama where they looked at 8 of their major reservoirs, that Tennessee River system and a few others. And they didn't see any evidence that there was ever any overpopulation. The density of bass in those lakes didn't seem to matter like it does in smaller systems. And that's likely just a function of the morphology and shape of the lake. We have so much surface area, so much light and energy entering the system. And then compared to the amount of shoreline, it's not that much. So, and even our recruitment levels, like our catch rates that we see, the average for us is right around 25-ish per hour of electrofishing. You look at some lakes in Eastern Kentucky and they're averaging like 100 per hour.
Yeah.
So we're not quite to that level. Now, if we had several year classes that were like that, 100 per hour, we might get to that point, which would be unfortunate because then the only solution is to harvest more bass. And that's a lot of bass when you're talking about Kentucky and Barkley.
Well, and that was another question that I had wrote down here because at the summit the other day, one thing that was brought up because of a lot of the lakes in further east they're dealing with that higher recruitment and an excess of recruitment and dealing with smaller fish because of that. And so the question that I had wrote down is, has catch and release as a whole gone too far? Has it, everyone talks about, you have to put that bass back. But I mean, first crappie they see that's 10 inches is going right in the frying pan. And the crappie population doesn't seem to be nearly as affected by that as some would seem. Like, what blows my mind is how there's still a crappie left in Jonathan Creek with how many get taken out of there.
Yeah.
And so would it hurt to harvest more bass or would it help to harvest more bass as a whole?
It's very dependent on whatever water body you're fishing. And even in your analogy there, crappie and bass, their biology is pretty different. And a lot of crappie anglers currently are trying to apply some basics about bass biology onto the crappie fishery, which is not the best way to do it.
As far as like turning back the big fish and
all that stuff is kind of, a carryover from the bass fishing and the bass biology, which has been very well studied, the effects of catch and release and releasing big ones. But for crappie, it's way more complicated, and that's a rabbit hole. I
don't need to go down.
If you got like 3 hours.
Yeah.
But yes, for the bass harvest, whether it's a good thing or a bad thing is very dependent on the water body. As you said, there are lakes that have excessive recruitment. You have so many bass that they stack up. It's a 8 to 12 or 13 inches. And there's just a bunch of those. They're skinny. They don't get any bigger. You may have a few bigger ones mixed in, but for the most part, if you're holding a tournament, you're weighing in 6-8 pounds, something like that, for your 5 fish, which is not what most people are excited about during a tournament.
Yep.
So yeah, there probably aren't any lakes where there aren't very many lakes. I don't want to exclude some outliers, but there aren't very many lakes where you would want to harvest, say, a 20-inch bass or 21 or 22 or even an 18-inch bass. But there's a lot of lakes that would benefit dramatically from harvesting 12-inch bass.
Sure.
Because you're reducing that competition at the small size. And more importantly, once you get to about 15 inches or 16, above that, the fish are more likely to be female. So you have that higher growth potential. So you don't really want to harvest females if you can avoid it. But the males don't have that potential to get to that large size. So if you could harvest more males, particularly at that small size, that not only eliminates that fish from the population, which was never going to get to a trophy size, it reduces the competition for those remaining females.
How does the average angler determine male or female?
The only way to tell is in the springtime. That you look at the distension of the eggs or not, and you can tell that when it's mature. There are things you could do, like sticking a capillary tube up there and seeing whether there's eggs or sperm that come out. And how far you can stick it in is also diagnostic. So that could be done. For the most part, you're just kind of looking.
Sure.
And then also a lot of the length limits are set up. And that's part of the logic for what Florida did with their statewide reg. That's 1/16. I think are they unlimited under or 5 under? I don't remember, but
not 100% sure on that.
You can keep 1/16.
Mm-hmm.
And the idea is that you're protecting the females at that point while putting more of the harvest pressure on the males.
Sure. Well, and it seems like that's been tried also in Kentucky, but the only way that works is if people buy into it and people do harvest those fish, because just because you can keep them doesn't mean that people are going to.
Yeah. And a lot of that, the blame can be placed pretty squarely on biologists. So when we put a slot limit on a lake, let's say it's a 12 to 15 inch slot, a lot of people take the message home from that specific regulation that the important thing is not to harvest, fish in that range.
Yeah.
That's not the important part of that regulation, even though that's specifically what the regulation states. Yep. The important part is we want to encourage harvest below that slot limit to free up that competition. And we do a very poor job and have done a very poor job of making that recommendation for harvest, like keep the small ones. We focus instead on you're going to get a ticket if you harvest some of those medium ones.
Sure.
So that's mostly our fault. But you're right. It does require some buy-in from anglers to put that harvest pressure on those small fish if you want to improve the population as a whole.
Sure. So obviously we talked a lot about the spawn and, issues with potential issues with fishing during the spawn, all that kind of stuff. What are the effects of, say, tournament fishing during the post spawn versus the spawn?
So during the post spawn, the primary effects would be actual mortality on the fish that are being caught. And that's primarily going to be concentrated in those summer months when the water temperatures are above 75 degrees. If they're below 75 degrees, even in a traditional tournament where you're putting 5 fish in a live well, and sometimes on our lake, driving them 40 miles wherever, you're not going to lose that many bass to mortality. Not that many are going to die. But above 75 degrees, the mortality can be pretty excessive. There are some studies that have been done on this, and a lot of the mortality is delayed, meaning the fish swims away, but it dies within 48 hours. And under the right or wrong conditions in a summertime tournament, the mortality rates can be as high as 70%. When I model the effects of tournaments in the summertime, I usually use a mortality rate of 40%. And again, a lot of that is delayed mortality. They've done studies where even fish that are in live wells with sublethal levels of oxygen. So below 4 milligrams per liter, more like 2 milligrams per liter. Those fish still swim away. They don't die until later, that delayed mortality. So I'm not throwing any stones to at tournament anglers or anything like that. I kill way more bass than you guys. I guarantee it.
Yeah.
Guarantee that. 100%.
Yep.
Killed thousands. But it is something to consider when you're looking and go, I do really good tournament care. All my fish always swim away. Well, they may not be living after that point necessarily, unless you're really, spot on with the tournament and live well care.
So not speaking logistically, just thinking about it logically, I guess, would it make more sense to put a ban on fishing for a 30-day window in the post spawn, or would it make more of a difference to put a ban on fishing in the spawn?
Well, what we know, at least, and this is very lake specific, in Kentucky Lake and Lake Barkley, the limitations of our fishery are recruitment based. We need that reproduction. As long as there's good reproduction, we have a good fishery. Poor reproduction, it's a bad fishery. It's not obvious to me that any fluctuations in our fishery are due to anglers killing adult fish, although that certainly does happen to an extent. But that's not responsible for those big swings, in my opinion. So now, which would be more beneficial, a 30-day ban during or post? I don't know, because you're talking about, there's another factor at play there, and that is related to genetics.
Sure.
So certain fish have certain genetic qualities, just like certain humans do. And some of those factors have to do with growth, maximum size, but also their levels of aggression and catchability. Those are heritable traits. And it's been known for some time that angling affects the amount of those traits that are within a population. So the amount of fish which are highly catchable genetically, they're just super aggressive. They fall for a lure every time, really dumb kind of fish. The only ones I catch. Yeah. Their popular, or their, I guess, proportion of the population declines over time as more fishing occurs. In the past, that was primarily influenced by harvest. Fish is more aggressive, more catchable, more likely to be caught and thrown in frying pan, dressed up in a cornbread tuxedo. But today's fisheries for bass are not really consumptive. So you can still see reductions in those genes over time, but it's primarily due to those fish being pulled off of beds where they're no longer able to reproduce for that season. So their genes aren't continuing in the population. Now, you do also see those effects, obviously, if you kill that fish during a tournament or hook it in the wrong spot or whatever it happens to be. So you lose some just because of fishing in general, but perhaps at a higher rate from summertime tournaments. So it all has an impact, but there's also a social cost to banning those kinds of things.
Sure.
And in my opinion, there are some good things that anglers could do to reduce that mortality during tournaments. Things like dropping to the 3 fish limit during the summertime, which is what a lot of tournaments around here have started doing. I think originally that was due to not being able to catch those 5 fish limits.
Yeah.
And now that's no longer the case, but you still see, okay, we've lost this resource before.
Let's not go back.
And some of that is just fear of they overestimate the impacts that their fishing had in the past. Like I said, the natural recruitment trends are the big drivers. It wasn't the fishing pressure or mortality, but every little bit helps. You don't want to kill an adult bass unless you have to, or just really want to eat it if that's your thing.
So the other thing that I'm sure you have had multiple people come to you and say, well, the simple solution is stocking. Is stocking a viable option on Kentucky and Barkley Lakes?
I would argue for increasing abundance that it's perhaps one of the worst. Well, no, I wouldn't say that. It's so big that it requires such a Herculean effort to stock enough bass to be able to see an impact that it's just economically unfeasible.
So what's the survival rate of a stocked fingerling? What can you expect to make it through that first year?
So one of the things that we look at to evaluate whether stocking has worked or not is called the contribution rate. And that's calculated pretty simply. So when the fish are stocked, we mark them in some way. Either clip off a fin, which will regrow, or we'll mark their otoliths with a certain chemical that glows under a UV light, or put a tag in them or whatever. Sometimes it's a genetic marker these days. You stock all those stock fish in there, and then you go back a year later in the springtime and you look at a random sampling of your population. And let's say you got 100, random age 1 fish. Then you look and see, okay, what proportion of those, what percentage were stocked fish? Usually in a large reservoir, it's going to be about 5%. And that is regardless of the stocking rate. So you can't really stock your way out of that problem. In some lakes or rivers do a lot better because the natural population is so low. But in some lakes, you could get as high as 20%. The average for across all water bodies, and I looked at, I believe, 75 different studies trying to figure this out to answer that question, because we had a problem with not enough fish at Kentucky Lake. So,
put more
a
in.
real linear solution there is put more in.
Yeah.
So I was like, well, what would it really look like? And the average is 20% across all water bodies, all those studies. But with those larger water bodies, and no one's ever tried something the size of Kentucky Lake, the average was more like 5%. And a 5% increase in the population, first of all, to do that, you would have to stock for about 15 years. That's because that 5% increase is only for 1 year class from one stocking. So you have to stock for 15 year classes to get that whole population up by 5%. And anglers would never notice an increase of 5% in the fish population. It would have to be probably a 20 to 25% increase to be noticeable. And the cost for doing that at Kentucky and Barkley is like $7 to $9 million a year to get that stocking amount, to get that 5% for 1 year. So at that point, it seemed pretty obvious to me that if you had $7 million to spend, you should go out and mark 7 fish with a tag and say, these are $1 million fish. We released 7 of them.
Yeah.
Come get them.
Yep.
If you want tourism to increase, you want to get activity, get some fun out there, you could do that, and it would be money better spent than a 5% increase in the population.
Sure.
So it's not really viable.
I mean, we should do that. It'd be kind of cool.
It could be done.
Does the budget allow for that $7 million for 7 tag fish?
Our budget does not.
Yeah.
I mean, I wonder, there are places that will do kind of, it's not a raffle, but whatever it is, something like that.
Gunnersville and Pickwick have it.
Yeah. And there are return, like tag fish where there are reward tags. And that's something biologists do. It's never $1 million, but we have reasons for putting the amounts on there that are fairly high so we could calculate return rates. But there are also like insurance companies that will insure, okay, here's your policy in case someone does catch this fish. Yeah. And so they're not usually spending $1 million each time. It's not sitting in a briefcase ready for somebody. But
sure.
That would be interesting. And if you had the money and there were no other opportunity costs that you wanted to spend it on, it'd be a cool idea.
Why not?
Yeah.
So, right now there is a stocking program that is happening on Kentucky Lake in the Tennessee part of Kentucky Lake. And it has for the last few years, through, I believe, Henry County is kind of leading that. I'm not trying to lead you into something where you're going to get beat up by your buddies down in Tennessee for this, but what are your thoughts on that? Is it, they're stocking Florida bass. What are your thoughts on stocking Florida bass? Obviously, you're not a big fan of stocking Kentucky Lake. Are they kind of, I don't want to say this in a rude way, are they wasting their time and efforts in your opinion?
So in my opinion, they are wasting their time and efforts, but it's not for the reasons I talked about a moment ago. So when you're stocking to increase abundance, all you get is that 5%, maybe 20% for each year class. And then it kind of goes away because those fish will die out. There's no benefit 30 years from now for you stocking that one time or multiple times. But what they're doing is stocking to change genetics. And that does work from a technical standpoint. So they're not, completely wasting money or misguided in that sense. And I know the biologists down there very well. Great guys. They do a lot to help the fishery. They're stocking Florida bass. And Florida bass are a non-native species of black bass. They're native to Peninsula Florida. And recent testing has found there are actually 3 different strains of Florida bass. One native to kind of Georgia, Alabama. Others native to Peninsular Florida. And then another strain along the Atlantic coast that are all Florida bass. And Florida bass have been stocked outside of their native range for the last 50 years in areas primarily at southern latitudes, although not at first. And they're stocked outside of their native range because they have a larger maximum size than our northern largemouth bass. And that's, the entire reason, basically. You're trying to grow bigger bass by putting those Florida bass genetics in there. The only problem with that in certain areas, at least one of the problems is it doesn't work if you go too far north. If you have conditions that are too far removed from what they have in Florida or their native range, it doesn't work. And you're better off with the northern largemouth bass, which can grow larger in those colder climates. The basic cutoff for that was figured out in Oklahoma back in 1992. They'd stocked all over the state of Oklahoma, and they found that it only worked at all in the lower half. And they plotted basically the severity of the winter and looked at that. And they found that the number of heating degree days was the most important factor for identifying which parts of the state where it would work, they would get bigger, or which parts where they would just die and not get any bigger. And they found that 3,400 heating degree days was that cutoff zone. If you have more heating degree days, that's just essentially more days where you're running your heater in the winter. So if you have 4,000, your winter is colder than if you have 2,000 heating degree days. 3,400 heating degree days splits Oklahoma kind of in half. It splits Arkansas. About the lower 2/3 of Arkansas are below that. Tennessee, it basically splits, right along that southern border. And then obviously in Kentucky, we're above 4,000, in some cases closer to 5,000 heating degree days. So we're much colder in a zone where it's not going to work. Now, Kentucky Lake, particularly the areas where they're allowing those county governments to stock, which they've done over the past 3 years, it's about 90 miles north of that suitable zone for Florida bass genetics. And it's in an area that is closer to 3,900 heating degree days. So it's basically kind of to the upper levels of what they saw in Oklahoma where it failed. So it's very likely, in my opinion, based on that research, that we won't see any benefits in terms of large fish based on those stockings of Florida bass. But from a technical standpoint, if they survive, they'll likely change the genetics of the population because it's still 5% that are being added each year in terms of contribution. But those fish can breed with the native fish and do so readily. And once those genes are in, they don't come back out. So it's kind of a cumulative effect. The more Florida bass you stock in, the more Florida bass genetics you'll have at the end of the day, and it's a permanent change.
So what's the negative impact? Obviously, the positive impact is big bass.
Yeah.
But there's obviously going to be some sort of negative.
Yeah. I mean, the negative in our area is that the climate is too cold for them to grow larger than our native species. If you go too far north, they grow slower than our native species. So the negative would be not only are you spending money on a project that might not achieve bigger bass, it might also achieve smaller bass. So it's kind of a double whammy in terms of that. There are also other negative effects of mixing different strains of bass. And this even includes mixing strains of largemouth from different areas where you see declines in reproductive ability as well as their immune system function and survival because you're mixing those genetics where you've got fish. There was a big study in 2002 that looked at this where they took fish from Wisconsin, they took fish from Texas, they took fish from Illinois, and they took fish from Florida. And those first 3 locations were all largemouth bass in a technical sense, but they're different genetically because they're in those different locations. Those bass are used to Texas winters, not Wisconsin winters. So what they did was they took offspring from all of those strains and they put them in ponds, 12-acre ponds in each of those 4 locations. So in Wisconsin, they had a 12-acre lake that had 300 Texas largemouth in it, 300 Illinois largemouth, 300 Wisconsin largemouth, and 300 Florida bass. And in all those locations, they did the same thing. And they found that in every single location, each 12-acre lake in all 4 spots, the native strain performed the best. It grew the fastest, it survived the best, at the highest levels of survival and reproduction. In Wisconsin, the Wisconsin bass were the only ones that survived the first winter. So even though largemouth bass from Texas are the same species as largemouth bass from Wisconsin, they're different enough and they're evolved to those local conditions enough that you don't want to mix them together.
Sure.
So it's, in my opinion, it's generally best, if you could, from an ideal scenario, collect your brood fish from the water body that you plan to stock, raise them in a hatchery, and then restock in that lake. That'd be ideal scenario. But you really don't want to move them over long distances. Now, the Florida bass has worked in those southern states to increase that growth, but only in areas that are similar to Florida in terms of climate. You go too far north, again, you're looking at negative impacts instead of positive.
So it's not as easy as just put more bass in, get big bass.
No, it's never that easy.
Yeah.
I mean, you look at places like Lake Fork in Texas that consistently produce trophy fish. That was helped by Florida genetics. That's why you got some bigger ones. They've stocked nearly every lake in Texas. They only have one Lake Fork.
Yeah.
There's only one OH Ivy.
Yeah.
And there's lakes probably within, casting distance of those places that probably suck.
Well, and that's was a big takeaway when we were at that summit the other day. TWRA joined our conference with virtually, and they kept on talking about all these lakes that they've tried it on. And they kept on coming back and saying, but Chickamauga, and, it's like Chickamauga is their one big success story for it, and Chickamauga seems like it was a perfect storm when they started stocking it with Florida bass and it really took off, and Chickamauga's done great with it. But it seems like there's been a lot of failures as well, or just not as successful.
Yeah, that's what it seemed like. And when you plot that heating degree day map across Tennessee, you see that Chickamauga is in that zone, or at least right on the border of 3,400 heating degree days. The new lakes they've been stocking they're above that. So I don't know whether they'll be as successful in those locations as they have been in Chickamauga. And then you also have, just on the whole, there's differences in what anglers want from a fishery. I've never fished Chickamauga. I've heard it's, they shut down after a cold front, really hard to catch. Yep. And that when you go down there, it's not like you're catching 75 fish a day.
No.
You're getting, I don't know. I mean, you guys have fished it. I've just heard it's a struggle to catch numbers. You might catch a big one, but you might not.
It's a completely different lake than Kentucky Lake. Obviously, just looking at it on a map, it's a lot smaller. It's a lot shallower. There's a lot less places for those fish to get. So yes, it pumps out giant fish, but there's not near as many places for them to go as well. If there was less places for fish to get on Kentucky Lake would also probably pump out even bigger fish because there'd be less places for them to go. So it's just a completely different animal than here.
Mm-hmm. And Tennessee is going to do pretty extensive testing to see how well that Florida Bass Project is going on Kentucky. They don't have any results on that yet in terms of growth, and you haven't seen real monster fish coming out of there yet. They have been stocking in kind of the southern part of it since 2015, and then since 2020 they allowed those county governments to stock essentially right on the border with Kentucky. So there'll be some results that come out of this, and it's very possible that some big fish could result from it. Very possible. The research could be wrong to an extent, and it is kind of borderline in those areas where they were stocking originally. But I think is the farther north you go, the less likely you are to have good results. And in my opinion, the money could be better spent either stocking other places that are farther south, or doing different management activities here in Kentucky.
Sure. One thing that I skipped over, just in general, what is the growth rate of a bass? Are we looking at a 15-inch keeper being 3 years old, 5 years old, 7 years old?
It varies based on the individual and based on the water body. But in general, on Kentucky and Barkley, it's going to take about 5 years to hit 15 inches.
So that's when we started to see kind of the upswing 2021 timeframe. That was your fish from your 2016 spawn class, which was a phenomenal spawn class.
Yes. Yep.
And then we'll continue to see that over the next couple of years as the next spawn classes continue to come up to that keeper size.
Yep.
So, and I guess we're at what that 2016 class would be. This would be year 8. So is that like a 3-pound fish?
You basically add an inch for each year.
Yep.
Once you get to that kind of year 5, 15 inches. So 16, 17, 18. And there's a lot of individual variability there too. And we're learning more and more based on research in other states, as well as researchers in China. And there's a private hatchery in Georgia that's done a lot of work on this about the importance of individual genes within the bass genome that allow some individuals to grow to the kind of the larger end of that spectrum compared to others that don't have the right genetics.
So I know we've kept you quite a long time. So I'll kind of finish up with this. What are you seeing as far as just a general overall state of the lakes? What are we looking at now? What are we going to be looking at in the next 3 to 5 years? And including in on that is obviously the bass, but also what are we looking at as far as bait fish populations, between all of the different bait fish?
Yeah. There's probably no way to predict, or if there is, I don't know how to do it, predict the number of bait fish in the coming years. They are so boom and bust that it's really hard to predict until you kind of observe it.
Mm-hmm.
So I couldn't tell you what's going to happen there. Hopefully we continue to see good shad spawns and, good healthy weights on these fish, which so far we've seen over the past few years.
What all bait fish also do we have in Kentucky and Barkley Lakes? The
primary forage would be threadfin and gizzard shad, or 2 shad species. You also have skipjack, although they kind of quickly outclass what a bass can eat. They grow much larger sizes. You also have emerald shiners in pretty good numbers, and silver sides, your other primary forage, which are smaller, but there's still quite a few schools of those too.
So what does 2024 say to you? Where are we at right now? Are we all 2 thumbs up, or are we just kind of in the middle? Hopefully it'll get better. What are we looking at?
I think we're on a great track based on what we saw with the recruitment, because we can know it takes 5 years to get to keeper status. So we can kind of forecast what's going on with the number of keepers up until that point. I don't know how the fishing is going to be in, 2032.
Sure.
But for the next couple of years, we should see an increase in the number of smallmouth. Although, based on the lake's history and the spawn that we had last year, it seems like the smallmouth is probably going to decline again, just as it's done in the lake's history. I could be wrong, but that's my best guess. But in the short term, I don't think we've seen anything yet in terms of the number of brown fish being caught. I think it's going to go up over the next few years as more and more fish get over 15 inches. The same thing with the largemouth. We had above average year classes the last 4 years in a row. Barkley had a really stellar year class last year, which hadn't happened in a while. So I think Barkley is going to have more keepers it'll probably be 3.5-ish years on Barkley because they have a little faster growth rate. So I think that's going to be a lot more viable as a tournament option in the summertime. Because right now it seems like you can win in the springtime, not so much in the summertime based on the numbers. You're better off fishing Kentucky. Luckily, they're side by side and connected,
yeah.
But it should improve on both. And Kentucky, like I said, largemouth and smallmouth numbers should be going up. And, it's very positive for what's going on with bass fishery right now. I can guarantee you it will be bad at some point in the future.
Yeah.
That's just what the track record
nature of everything.
Yeah.
Well, Adam, I really appreciate you. I know this was a long one. This is something that I've been very excited about to talk to you about because it's something that, we all here are passionate about our lakes. And you've got a wealth of knowledge. And I know you don't want to take credit for anything that's happened over the course of the last several years, but we definitely appreciate your efforts in continuing to improve Kentucky and Barkley Lakes. It has not gone unnoticed for sure. We really appreciate it. And we appreciate you being so willing and open to just sit down and discuss it all.
Yeah. Thanks for having me on. I love doing podcasts because there's no presentations. You got to prep. You just
We're just
show up and get grilled.
Yep. Well, we appreciate it again. And I'm sure if you're willing, we'll probably have you on at some point in the future as well.
Yeah, that'd be great. We can talk about crappie or whatever you guys want to talk about. But
absolutely,
crappies be a hot button issue, and forward-facing sonar, all that stuff is.
Oh yeah, the controversial stuff.
Yeah, that's some good stuff.
All right. Well, we appreciate it again.
Yeah. Thanks for having me.